Hello everyone, welcome back to my YouTube channel Leon Practice for Cracking IIT and Neet. So in the last video we had discussed about what the introduction of I effect, either plus I or minus I. Overall, I is nothing but what polarity of sigma bond depending upon the generation of modified electronegativity. Modified electronegativity. So here, what are the factors of plus I effect? Plus I is nothing but it is inversely proportional to modified electronegativity. That's why first factor is what? Excessive negative charge. Second factor is what? Here lower electronegative molecule than carbon. Third factor is what? Here alkyl group. That alkyl group we have to follow what? deviant rule. Last one is what? Hydrogen isotopes. Hydrogen isotope. That is the sequence of the plus I atom. Second one minus I. Minus I is what? Electron withdrawing group. So it is directly proportional to the modified electronegativity, not electronegativity. The modified electronegativity. So how to find the overall order depending upon this modified electronegativity? First one is what? Complete excess positive charge or complete positive charge. Second category is what? Partial positive charge. Third one is what? Here. Third one is what? Here. Elemental. Actually it is not elemental. Alone element electronegativity, because it should be connected to organic substance, so you should not say elemental. Alone element electronegativity and group electronegativity. The last word is what? Hybridization. Among hybridals, how to find the electronegativity? Yesterday we had discussed, which means in the last class, right? Now, so here one more thing is there here that sp3 hybridization NBPR rule is there. That NBPR is called actually field effect. Field effect. So in the last class that OH, OR is there, sp3 hybridized O oxygen atom is there, OR is what? Sterically crowded, that's why it is elongated, like this bond angle is extended. So due to extension of this bond angle, S character is also increased. More S character, more electronegativity, that's why here OR is greater than OH according to minus I effect. OR is greater than OH, that is called actually what here? Field effect. High inductive plus field effect. You may get what here? Exception condition in our mind like this. Actually, in between OH and OR, R is having some kind of plus effect. So you may expect here OH is more electronegative than OR. That is wrong. So according to field effect here, OR is greater than OH. OR is greater than OH. So this is about what here? Introduction of plus I and minus I. What are the orders we had discussed in the last video. Now in this video we are going to discuss about the applications of inductive effect. Applications of inductive effect. So before going to discuss about these applications of inductive effect, we must know here intermediates in the organic chemistry. So in the universe of the organic chemistry, there are only two types of bond breakage. Only two types of bond breakage. First one is what here? Homolytic cleavage. First one is what here? Homolytic cleavage. So equal contribution of the electron. Here actually bond pair electron is there. So two electrons, one bond contains how many electrons? So one BP, which means bond pair of electrons. Two electrons are present. So if it is getting what? Equal contribution of electron cleavage. So this is called what here? Homolytic cleavage. Homolytic cleavage. So homolytic cleavage, generation of which one here? What is the intermediate? These two are intermediates. So these are called what here? Radicals. These are called radicals. Is it clear, beta? Radicals. So due to which one? Homolytic cleavage. Equal contribution of the electron after getting broken here. That is what here? Radical generation. First point is what here? Radical generation. Second one is what? Heterolytic cleavage. Second one is what here? Heterolytic cleavage. What is heterolytic cleavage? For example, here CC bond is present. Of course, it is also having what? Two electrons, BP electrons. If these two electrons, depending upon the En difference, modified electronegativity, if it is polarized towards one of the carbon, complete BP is polarized towards one of the carbon. So that carbon is getting what here? Negative charge. So this remaining carbon is getting what here? Positive charge. Actually, in organic chemistry, what is the symbol of positive charge? What is the symbol of negative charge? Symbol of positive charge is nothing but empty orbital. Generation of empty orbital. So C plus is nothing but here? Generation of empty orbital. Generation of empty orbital. Generation of which one, beta? Empty orbital. What is C minus? C minus is what here? Lone pair. LP. Yes or no? This BP are polarized towards this carbon. Now that's why it is getting negative charge. So this negative charge is called here what? Carbonium. This is called carbonium. Carbonium. This one is called what here? Carbocation. Carbocation. This is called carbocation. Now, so in the universe, there are only two types of cleavage in organic chemistry. Those are what? First one is homolytic cleavage. Due to homolytic cleavage, what we can get here? Radicals. So next one here, heterolytic cleavage, we can get what? Carbocations and carbonions. So these three are called intermediates. What does it mean? What is this intermediate? Intermediates are nothing but here the lifetime of that substance is very less. Is very less. So those are called intermediates. Do we have only these three or these three intermediates? Of course, we may like carbene also present, nitrene also present. Yes, sir. Do we have only these three intermediates? Yes, these three only possible actually. In the organic chemistry, only there are three major intermediates. What are those? Radicals, carbocations, carbonions. Let's see what is the structure of this one individually. So carbocations are nothing but here there is normally three bonds, maybe double bonds or single bonds, whatever, which means here actually what is the hybridization method? This one is what? Sp2 hybridization. So carbonium is sp3, but we cannot fix it here depending upon the structure. So we have to decide here, that we will see later. Next one is carbon radical representation is like this, which means it is one single unpaired electron. Next here there would be three bonds, whether it is pi or sigma. Now it is also having sp2, but that is not fixed. So depending upon some orientation we may decide sp2 or sp, that we will discuss later. Now here normal hybridizations, sp2 mean in this structure 3 sigma bonds carbocation, which means empty orbital, 3 sigma bonds carbonium sp3, 3 sigma bonds 1 unpaired electron sp2. So hybridizations are sp2, sp3, sp2. So sp2 is nothing but what is this here? Planar geometry. Here is what here? Pyramidal shape. Pyramidal shape. Next here is what here? Planar. This is also having what here? Planar. Now the free orbital is what here? This is a free orbital. This is a free orbital. This is a free orbital, empty orbital, indicated by what here? Plus. Now this is what here? Lp. This is what? Lp. This one is what here? One unpaired electron, one unpaired electron, one unpaired electron. See the structure now. This is what here? Triangular planar. This is what here? Pyramidal. This is what here? Triangular planar. So empty orbital. Next one is what here? One Lp. Next one is what here? One unpaired electrons. So in the universe of the organic chemistry, there are only three intermediates. Then what about those carbenes? Singlets we have, doublets we have, triplets we have what? Singlet and triplet intermediates also there, carbenes. So how it is forming? So these are actually called primary intermediates. These are actually primary or major intermediates. Second one is what here? Supplementary intermediates are there. What are those? Listen carefully, this is very interesting. So what are those supplementary intermediates? Only there are three intermediates: carbocation, carbonium. Next one is carbon radical. Now I am taking here one carbocation. This is the carbocation. Second one is what here? Carbonium. Carbonium is the third one is what here? Carbon radical. So now here, if you mix these two, this is the first condition. If you mix these two, this is the second condition. If you mix these two, this is the third condition. Now what is happening here? This is the empty orbital, which means carbocation. First of all, let's see combination of 1 and 2, this 2. So here what? Carbocation. Next one is what here? This one is what beta? Carbonian. Carbocation, carbonian, which means here two bonds are there. Two bonds are there. One lobe is having empty orbital. One lobe is having what here? LP, lone pair. So this is called singlet carbene. Am I right? Singlet carbene, combination of carbocation and next one is what? Carbonian. That is called here singlet carbene. This is what here? Singlet carbene. So singlet carbene. Singlet carbene is having what? Electrophile side as well as nucleophile side. What are electrophiles, nucleophiles? We will see. Now here what? Carbocation, carbonian. First one is what? Carbocation, carbonian. Second combination between these two. Carbonian, next one radical. Carbonian, radical. Mixture of these two lobes. Now here it is having normally two bonds. So one lobe is having here pair of electron. One more is having what? Unpaired electron. So this is called radical carbonian. This is what beta? Radical carbonian. We are not discussing about hybridization here. That we will see later. Hybridization, all types of hybridization. But here just the possible intermediates in organic chemistry. So these are the only primary major intermediates. Carbocation, carbonian, radical. Cation, anion, radical. That's it in organic chemistry. There are only two types of bond cleavage: homolytic and heterolytic cleavage. First set is over. Singlet carbene. Second one is what here? Radical carbonian. So one more intermediate is the third combination. What is that? Third combination. What is that beta? Third one is what? Carbocation, radical. Which means here, so there are two bonds. One lobe is having unpaired electron, that means radical. Second lobe is having empty orbital, that means actually positive charge. So this is called what? This is what here? Radical carbonian. In the same way, this is called what here? Radical carbocation. But in the nature it does not exist. Radical carbocation is not existed in the nature. Why? We will see. So these are the probabilities only. So based on which one here actually existence of any intermediate substance. So there are only three kinds of stability. This stability is very important in the organic chemistry. So stability, how many types of stabilities are there? First one is electric stability or electrically stabilized. Okay. First one is what? Electric stability. Second one is what here? Spherical stability. Second one, spherical stability. What is the third one? Third one is what? Electronic stability. Of course, we are discussing this last one only. Electronic displacement effects. So this we are considering. Most of the times we may only think about electronic stability. That's wrong. First one we should consider electric stability. Next one is what? Spherical stability. The last factor is what here? Electronic stability, which means we have here inductive effect, mesomeric effect, resonance, hyperconjugation. All the effects are present in the last one, but which is least effect actually. First thing is what? Electric effect. Second one is what here? Spherical effect. Third one is what here? Electronic effect. What is here? What is the difference between electric and electronic effect? Let's see. One. Now if you take here CH4, right? Methane. Next one is what? Methyl carbocation. Next one is what beta? Methyl carbocation. First one, what is the charge of this molecule? Charge is what here? 0, which means this is a neutral particle, neutral molecule. Second one is what? Charged particle. Second one is charged particle. Now, which is more stable? Which is more stable? We know which is more stable. Methane is more stable than methyl carbocation, isn't it? Methyl is more stable than methyl carbocation. What kind of effect here? What kind of stability? First one, electric stability depending upon charge or neutral. Charge or neutral. Neutral particle is stable than charged particle. Right? First one is clear. Electric stability. Now let's see the last one. Last one is what here? Depending upon electronic effects. Depending upon electronic effects. Here carbocation is there. Carbocation. Both are charged particle. What is the first one? Electric. No, this is not neutral. It is also charged particle. This one is also charged particle. Both are charged particle. So there is no electric stability. There is no electric stability. But electronic stability we can find. Lifetime of these two are very less because these two are intermediates. But among the lifetime of those, we can find out which is somewhat stable, which is somewhat less stable. Here, what is the effect? The order we know already. This is what here plus a effect. Here also plus a effect. Two carbons. DBN rule. DBN here number of carbons are more. So which means second one is more stable. Yes or no? This we can find here. Second one is more stable. See the difference here. This is called what here? Stability. First one is what? Electric stability. Second one is spherical stability. Third one is electronic stability. Spherical stability is also one of the important factor in organic chemistry to find the proper answer. So we may not think about the spherical condition. We are always focusing on electronic rules only. Whether it is plus I, minus I, plus M, minus M, resonance, hyperconjugation, reverse hyperconjugation, whatever it is, we should consider this point also. Now this is the difference among electric stability, electronic stability and spherical stability. Spherical stability we will see later. Okay. So this is the difference among these three stabilities. Now here let's see why it is not existed in the nature. Why it is not existed in the nature. So before that, the combination of carbocation and carbocation. Combination of carbocation and carbocation is not possible. It is not possible. Why? This is what here electric stability. Charged and charged, that too positive, positive. Positive is what? Repulsive forces are there. Stable or unstable. The combination gives what? Good combination or bad combination. So worst combination here. So this is unstable. Electric stability is not there. That's why the combination of carbocation and carbocation is not existed. Is it clear? Is not existed. Next one is what here? Combination of carbonium and carbonium. Carbonium. Again, it is also not existed. Because of what here? Electric stability. Because of what here? Electric stability. Third one is what? Third one is what here? Carbon radical plus carbon radical. Of course, radical is neutral. Radical is not charged particle. Radical is not charged particle. Only carbocation and carboniums are charged particle. Plus and minus. Radical is neutral. Neutral. That is okay. Neutrality is there. Electric stability is there. But there is no electronic stability. Electronic stability is nothing but we have to consider most of the conditions. Octet in the valency. Octet in the valency. Now it may be reacted. Now this combination, okay, neutrality is there, so it may be combined. Now it is giving what here? Two sigma bonds normally. Next one is what here? One orbital is having one unpaired, one more is having one unpaired electron. Yes, this is called triplet. This is called what here? Triplet carbene. This is called what here, beta? Triplet carbene. So these are the combinations of intermediates. Singlet carbene, radical carbonium, radical carbocation. Next one, these two combinations are not existed. These two combination is not existed. This is existed. That is giving what here? Triplet carbene. So these all the combinations. Mixture of primary intermediates are called supplementary intermediates. These are called supplementary intermediates. So total, how many we have got here? First one is what? Carbocation, carbonium, carbon radical, radical carbonium, radical carbocation, and triplet carbene. These two are not existed. Let's see now. Which are stable? Which are more reactive intermediates? Which are stable? Which are more reactive? Intermediates. 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 First one is what here? Carbocation. Carbocation. Second one is what? Carbonium. Third one is what? Single electron. That is what here? Radical. Fourth one is what? Negative charge and radical, which means radical anion. Radical anion. There would be normally two bonds. Next one is what here? Singlet. Singlet. Next one is what here? Singlet, two bonds. Next one is what here? Triplet. Triplet and two bonds. The last one is what? Carbocation radical. Carbocation radical. So all we have discussed just now. What here is what? Carbocation, carbonium, radical. This is what? Anion, radical anion, singlet, carbene. These two are carbenes, singlet and triplet. Pair of electrons means what? Combination of anion and empty orbital. Anion and cation, anion and cation. This one is what? Combination of radical and radical. Radical and radical. This one is what? Combination of carbocation and radical. So these are the possible intermediates. These three are called, first three only the proper intermediates. These are called major or primary intermediates. These are called supplementary intermediates. Supplementary intermediates. Now let's see here electronic neutrality. Next one electric neutrality. First one, find out the number of electrons, total valency electrons, total valency electrons, total valency electrons. First one, how many? 3 bonds, 6 electrons, empty orbital, which means it is having 6 electrons, right? First one, carbocation is having 6 electrons. Carbonium, anion is nothing but 1 Lp, 2 electrons and 3 Bp. Total how many electrons? 8 electrons. 8 electrons. Carbon radical, so 3 Bp and 1 unpaired, 7 electron. 1 unpaired, 7 electron, right? Next one, 2 Bp, 1 Lp, 1 single electron. Total there are 7 electrons. Total there are 7 electrons. Next one is what? 2 Bp, 1 unpaired electrons or pair of electron. Now this is having 6 electrons. It is also having 6 electrons and it is having how many? Yes, there are also 2 bonds. 2 bonds and 4 electrons, empty orbital. Now only 1 electron is there. That is what here? 5 electrons. In the valency, there are only 5 electrons for radical carbocation. For which one? Radical carbocation. Radical carbocation. Next one is what here? Electric stability. Charge. About charge. Electric stability. So which is electrically stable? Which is electrically stable? Electric stability is nothing but charge. So what is the charge of this one? Positive, which means it is a charged particle. It is a charged particle. Carbonium, carbonium, it is also charged particle. Carbonium, it is also charged particle. Radical, there is no charge. There is no charge, which means it is neutral. This is neutral. Now here anion is there. That's why it is what here? Charged particle. Charged particle. Charged particle. Next one is what here? Next one is what better here? Singlet. Singlet is what here? Neutral. Singlet is what here? Neutral. Next one, triplet. It is also neutral. There is no charge. There is no charge. There is no charge. Next, here. Here is what here? Positive charge is there. Positive charge is there. Actually, it is not about charge. So it is also neutral. It is also neutral because there are only 5 electrons. Now neutral. Now neutrality, check it here. Neutrality, first 2 are charged particle. Next one is, this is what here, charged particle. Remaining all are neutral particles. Neutral particles, which means these are less reactive particles. less reactive particles. Radical is less reactive. Next one is what here? Singlet, triplets. These two are also less reactive. Okay. Now here let's see the electronic stability. Electronic stability. Electronic stability. Electronic stability is about what? Octet condition. Octet condition. So now out of all, only one thing we may decide here. 6 electrons. So 2 electrons are required to get octet. 2 electrons. Here already octet condition is there. Here 1 electron is required. Here 1 electron is required. Here 2 electrons are required. Here 2 electrons are required. Here how many electrons? 3 electrons are required. So it is electronically what here? Unstable, because it requires what here? 3 electrons. It requires 3 electrons from the other substance. So this is not existed. That's why it is not existed in the valency. It is having only 5 electrons, which requires 3 more electrons to get noble gas configuration, electronical stability, octet condition. That's why out of all, this is not existed. This is not existed. So that is the matter here. Now in between, of course, charged particle is there. So negative, positive charged particle is there. Now for example, if you think here stability of charged particle, stability of here positive and negative in the what is that nature? So which is more stable? First one is what? Charge and charge. Charge and charge. So there is no electric stability. Both are charged particles. Both are charged particles. But here actually electric stability, okay, charged particles not there. Now here how many valency electrons are there? How many valency electrons are there? 8 valency electrons are there. 8 valency electrons, and it is what? Insufficient. 6 valency electrons only. So it requires 2 electrons. It can donate 2 electrons. Now most of the condition, the reactions are occurred in between these two types of intermediates. These two types of intermediates, because these two are charged particles. So mutual understanding. It requires 2 electrons. It can donate 2 electrons to get what here? Electronic stability. Electronic, there is no electric stability. Both are charged particles. But to get electronic stability and as well as electric stability, so contribution is there, donating capacity or accepting capacity. So most of the reaction mechanisms are carried out by these two types of intermediates. These two are more reactive compared to all the other supplementary. Now if you want to find a primary, among primary, radical is less reactive. Radical is less reactive. Why? Because radical is having electric neutrality. This is electrically unstable. This is also electrically unstable. But this radical is having neutral. Of course, one more thing, it requires only 1 electron. It is very near to octet condition. Which means indirectly it is stable. Just only 1 electron is what? It requires only 1 electron. That's why it is near to stability. So two conditions here. It is near to stability and there is no charge. That's why in the nature radical is less reactive. Compared to carbocation, carbanion, radical is less reactive. Now, here we have to find the primary intermediate stabilities. By using that inductive effect. Let's see now applications of inductive effect. First one is what? Plus-I effect. Due to plus-I effect, what will happen? Plus-I effect is nothing but here any electron donating capacity. Okay, that atom or element or molecule, whatever compound is having what? Electron donating capacity. That is called what here? Plus-I. This is called what here? Plus-I. If any group which is present on organic chemistry, it can accept, which means electron withdrawing group. So that group is having what here? -I effect. Now how to find the intermediate stability? So carbocation, it is electron deficient. To get octet condition, to get electronic stability, it requires electron density. So any electron donating element is present, it is easily stabilized. That's why carbocation is directly proportional to plus I. Now carbocation is inversely proportional to minus I. So this is the order. This is the order of the stability of carbocation intermediate. It is electron deficient. If you take here electron excess carbonium, carbonium is electron excess. 8 electrons with Lp, electron density is present. So if any electron withdrawing group is present, now the charge is diminished. The charge is decreased. The charge will be decreased. Charge will be decreased. Then electronic stability what happened here? Sorry, electric stability what happened? Increases. That's why here what is the factor we have to choose? Any electron withdrawing group directly proportional to minus I and inversely proportional to plus I. Inversely proportional to plus I. So this is the order of the carbocation and carbonium. One more is a carbon radical. Carbon radical is already electrically stability, that is okay. Neutral part, but here electronic stability is not there. So here it is also what? Electron deficient. It is also electron deficient. So any donating atom or molecule or compound is present, it is easily stabilized. That's why directly proportional to plus I and inversely proportional to minus I. Inversely proportional to minus I beta. So this is the overall order of intermediate, prior intermediate, major intermediate stabilities. What is that? Carbocation is directly proportional to plus I, inversely proportional to minus I. Carboniums are stabilized by minus I and destabilized by plus I. Carbon radicals are stabilized by plus I and destabilized by minus I effect. Minus I effect. Now, one example. Maybe carbocations, carboniums, carbon radical. Let's see the stability order. Let's see the stability order. Okay, one by one. Check it better once. Let's see the applications now. Stability of intermediates. Stability of intermediates. First set is what here? CH3, CH3, CH2 carbocation. Second one is what? CCC carbocation. Next one is what? CC 4 degree carbocation. In same carbons, carbonium, carbonium, carbonium. Now stability. So what is the role of methyl? What is the role of methyl? How to find this role of methyl? Same thing here. En difference. There is a just En difference. This is what? Completely positive charge. This is neutral. More electronegative. So here electron withdrawing group. This is electron withdrawing group, but it is having what is the effect? Plus I. We have to choose the methyl condition here. Plus I effect. Here also plus I. This is also having plus I, but two methyl groups are present. Here also it is having what? Here plus I. Three methyl groups are present. So for stability of what here? Plus I effect. What is the rule we have to choose here? DBN. DBN. Distance, branching, number of carbons. Distance, branching and number of carbons. Carbocation directly connected. Directly connected. Directly connected. Now here branching is there. So this is having what here? Branching 1, 2, 3 branches. More branching, more it is stabilized. So what is the order here? 3 degree carbocation is stabilized by 2 degree. 2 degree is stabilized by 1 degree. So this is the stability of carbocation according to plus I. Second factor is what? Of course here what here? Plus I effect. This is also having plus I effect. This is also having plus I effect, but the last one is having more plus I effect. So due to more plus I effect, electron density on carbon what happen? Electron density on carbon what happen here? Increases. Electron density, suppose it is increased like this, or it is increased certain extent. Now it is increased too much. So more charged particle. More charged particle is electrically unstable. Electrically unstable. Then stability what happened? Will be decreased. Stability will be decreased. Now here this is greater than this one and this will be greater than this one. So this is the order of stability of carbonions. So if you choose here carbon radicals. So single radical and 2 methyl radical and 3 methyl radical. Same concept. Only one methyl donor. Here 2 methyl donor. Here 3 methyl donor on direct to the carbon radical. So here more electron donating capacity is there. Due to more electron donating capacity, stabilization is also increased. So what is that here? This is the order. So stability of carbocations, stability of carbonions, stability of radicals. Now find out one answer here. CH3 plus, CD3 plus, CT3 plus. Next set CH3 minus, CD3 minus, CT3 minus. Next one CH3 radical, CD3 radical, CT3 radical. So find out the stability order. First one is the stability of carbocation, second one is carbonion, third one is the carbon radical. First one is what? Hydrogen donor, deuterium donor, tritium donor. So here bond length is very less. It can donate strongly or immediately electron density to carbocation. So stabilization what happened? Will be increased. This is what here? More stable. This is more stable, right? So this is the stability order. This will be the stability order. Check it better. This will be the stability order. Second one, of course, third one you may take same condition because a carbocation stabilized by plus side. At the same time here, carbon radical is also stabilized by plus side effect, which means here last set is also same. It is also having same trend. The second middle one, more donating tritium, more electron density. It has more electron density, electrically unstable. That's why stability order is reverse. Stability order would be reverse, right? Check it. Now one more set of carbocation set. There would be 3 carbons, right? Next one is 4 carbons, right? Next one is also 4 carbon. Next one is having 4 carbons, extra 4 carbons. Now stability order. For the alkyl plus I effect, choose it. Distance and branch and number of atoms. Sequence beta. First we should follow distance. Second thing is what? Branch. Third thing is what? Here number of atoms. So first carbon. So this is having only one branch. This is also having only one branch. This is also having only one branch. And this is having what? 2 branches. 2 branches it is. So after distance, what is the factor here? Branching. That's why first it is stabilized because carbocation is stabilized by plus I. So it is having more plus I. First one is over. Yes or no? First one is over. Second one here. This carbon is same type of branching. Then go for the second carbon. This carbon. Now here this carbon is having only one branch apart from this area. Only one branch, and this carbon is having 2 branches. This is also having only one branch, which means 2 branches is more stabilized. Now in between these two, so here there are only 3 carbons of plus I effect. There are 4 carbons of plus I effect because here distance branch is same. Only factor is here number of carbons. So number of carbons for the last molecule is more. That's why that is the third in the order. Now the last one is this. This one is the last one. So this is the order of plus I. Anyway, if alkyl group is there, so you should follow only DBN rule. Use this DBN rule trick, then you will be able to find out the proper trend of carbocation stability. Proper trend of carbocation stability. Then one more trick is there for minus I effect. Minus I, what we have to consider? Distance we have to consider, or number of atoms we have to consider. Next one is what branching we have to consider. What we have to consider, that we will see in the next. Check it better once.